see my screen? Can anybody confirm that, please?
Yes, yes.
All right, perfect. All right, so yes. Okay, let me make sure I'm recording. Yeah, it's being recorded. All right, so basically this week we're going to complete with everything related to the theory, and then next week we're just gonna do a few practical, and then that will be it. So and then we're just gonna set up a deadline for the mock exam and set up the exam date. All right. So all right. With that being said, today I wanted to kind of recap from the beginning, like kind of go through all the material we went through, and just to give you an opportunity to actually ask any question about any part or comment or anything like that. So we all have an understanding of the whole course. Because I've seen sometimes during the class, especially when we're talking about, we ask some questions and then you can see some answers from some people. You can see that, okay, they still have a big misunderstanding of AI itself. Okay, so we're gonna go through this faster because, and I'm gonna be asking you a few questions, and as we move along, or if there's any concept that you don't understand, please ask a question. So this today's class is really gonna help you kind of create the whole picture of the whole course, so that it's very easy for you, even when you're preparing for your mock exam or preparing for the main exam, you have a whole idea of AI and everything that is expected from you. Okay. All right. So when we started with the overview of AI. I'm sure by now everybody knows what is AI, and there's no issue with that, right? So we don't have an issue to really describe what is AI, and yeah, so that is everybody have a basic understand the basic concept of AI, AI technologies and development histories. We have application technologies and field of AI, and then we also have the Huawei AI development strategy and different AI trend. Okay, so when we started with understanding that AI is not something new. It's something that started in the 1950s, and the person who's considered to be the father of AI is John McCarthy. Yes, the question came from Alan Turing. Alan Turing came with the question to know if machine can think, and then John McCarthy came with the idea of creating a science that will be creating machine that can actually do what will need more intelligence if it's done by humans. So and then from Alan Turing idea that when we spoke about the Turing test, does anyone remember what is a Turing test? Most of the question I will be asking you are type of questions that you have on your exam. Does anyone remember the Turing test? How did Alan Turing method? How does it work in order for you to respond to the question, can machine think? Can anybody remember what was done to check if the machine can think? What is the Turing test?
I think it's where they were like asking questions, then they will let a machine like answer that question, then they would see if that answer was like more human or like more machine.
Yeah. So no. Okay. You are 50% right. But the way the Turing test work is that they will put a human, right? They will ask a question to the machine will answer, and then they will bring a human who will detect, who will say if the answer that was presented there is coming from a human or from a machine. If the machine is able to fool a human, that a human can look at that answer and say, no, this comes from a human being, but yet the answer came from the machine, then we can consider that that machine can think. So the Turing test is all about a machine fooling a human. Okay, so that's the Turing test. So remember, we started with the Turing test, and then we have John McCarthy that came with the whole idea of creating a that will actually create all these intelligent machine. And from there, we have people like Mervyn Minsky who came with more details into how we're going to create this machine. And everything was based on different type of intelligence that human being have already. So human being, we have many type of intelligence. We have, for example, linguistic intelligence, which is found in people who like motivational speakers. You know, there's people who, when you put them on a public platform, they know how to talk. That is a type of intelligence. So our education system has made us believe that in a class of 50 students, as soon as there's a student who's very good in mathematics, they call that student intelligence. Why? Because they only focus on one type of intelligence, which is the logical intelligence. So this logical intelligence in our society or our school background is the only intelligence being recognized out there. If a student is good in maths, physics, then they say this student is smart, right? While there's many type of intelligence, you have linguistic intelligence, you have visual intelligence, which you find in artists, someone who can make a certain drawing and they have a big understanding of that. You have kinetic intelligence or bodily intelligence, which you find, for example, in athletes, soccer players, basketball player, or any type of sport that you have. You have musical intelligence, interpersonal. So you have all these type of intelligence that humans have. So we can now create the machine that can do these type of things. For example, you have your Siri on your phone, which is an AI tool which is actually empowered with linguistic intelligence. So you have different type of AI which can represent a type of intelligence. Okay, what is exactly artificial intelligence? So you must also understand artificial intelligence is a field of studies to make machine think like human. It's a field of studies to develop different theories, techniques, and application systems which can simulate and extend human intelligence. So it's all about simulating human intelligence. It's not about replacing human. It's not about fighting human. It's about doing something that will require more intelligence from human. Is if a human cannot do 5 million calculation at the same time, let the machine do it. So that's all what the whole purpose of AI. And we need to understand that to create this AI, there is a lot of science that comes into the game. So you have computer science because we are using computers, right? And then we have a different science like linguistic and cognitive science. We have neuroscience because why can anybody tell us how is neuroscience knowledge helping AI? Okay, because remember when we talk about neuroscience, we're talking about the study of the human brain. How can the study of the human brain help the development of AI? Can anybody tell us?
To think like a human being.
How? How can machine think like human being? So what knowledge did we as AI developers, what knowledge did we take from neuroscience? Guys, what's knowledge? What knowledge did we take from neuroscience? in the development of AI? Anybody?
I think it's the way human brain works. So, since AI is about like simulating human minds, so I think we use neural networks like
Mhm.
to simulate the way how the human brain works.
Yeah, that's the right answer. Because in AI we use a system of neural networks. That means that we take different information which are saved in different nodes of your neural network. So basically, uh, the way if I ask you, and if I tell you the name of what's name can I give you? Okay, if someone asks you for the name of a friend of you, a friend of yours, any type of name, any friend of yours, when they mention the name, what does your brain picture? Your brain picture the face, right? When you picture the face, somehow you picture every feature of the face to identify them. If this friend of yours has a big nose, you will remember that nose. If they have small eyes, you remember that. So you have all this information in your brain. That's the same way the machine will work. So the machine, when it looks at this picture, it's going to have an input layer. And in this input layer, we're going to have every single feature. Maybe this first node here is going to have the information about the area around the lips. This one maybe around the nose. So all these information in the neural networks, right? In the type of neural network where we have all these connections here, we create a relationship between this information up to the point where we're going to get an output to say this is John or this is not John, right? So because of this structure of working with things, that's the same way the brain works. So how our brain works with neurons, where there's different information and different information put together will come up with a certain output. So that's the structure that AI developers took from neuroscience, the way the brain works in terms of handling or dealing with information. So that's what we took from that. So there's many sciences that have that we've taken some type of information in order to create all these AI tools. Okay, and then we talk about the relationship between machine learning, AI, and deep learning. We need to understand machine learning is the type of algorithm used to create AI tools. So an AI tool is composed by four elements. We need data. So these data are the data that we use to train the machine and data that we're going to use as we're using the machine. We need the algorithm, which is the code, which is machine learning. So we need algorithm, we need computing power, which is any hardware that we're going to use, and then we'll need application scenario, which is the idea that we have. So whenever we have an idea to create an AI tool, we will think and ask ourselves, what problem are we solving? And then we see, okay, fine. How are we going to collect the data? We get the data, the type of all algorithm we're going to use. And the computing power will be all the CPU, the GPUs, and every device or all the servers that you're going to use in order for you to train the machine or to use the machine. Now, the machine learning will be the part of AI where we're going to teach this AI how to understand this data through this algorithm by the help of these computing powers in order for us to achieve the application scenario that we had. So what the relationship now between machine learning and deep learning? Just understand deep learning is part of machine learning, but deep learning are advanced algorithms, which started from the year 2010, which are called deep because of the amount of layers that we can have in the neural networks. So whenever we're dealing with all the type of neural networks, we must understand we're talking about deep learning, because machine learning, talking about machine learning alone can involve a simple algorithm like the regression, linear regression and logistic regression, those simple algorithm. Okay, but when we talk about advanced algorithms such as the CNN, the RNN, and all those algorithms, we understand that we are talking about deep learning. All right, so understand deep learning is part of machine learning, and machine learning is just the core of AI that has to do with creating all these this algorithm in order for us to achieve our scenario. Okay, so and then now to try and see what methods we can use in order for us to create this machine, we have what we call the schools of AI, the schools of thought. Schools of thought is how do human beings deal with information? When they tell you a monkey, somehow your brain has already pictured how a monkey look like. You don't care the size of the monkey or anything, but you just have this picture of you just picture a certain monkey that you've seen, right? So we have three schools of thought. We have symbolism, we have connectionism, and we have behaviorism. So symbolism, also called logicism or psycholism, okay? This refer to the symbolic AI that is derived from mathematical logic. So basically, to kind of understand what is symbolism, you must understand everything, every object is seen just as a symbol. Okay, so when we look at symbolism, we can see certain algorithms, simple algorithm that will just look at a certain picture because it has a certain size or it looks like something, like a certain shape. The computer can already detect that picture. For example, you look at fruit, you look at an apple because it looks like this, because the fruit looks like this. The machine look at it, okay, look at the size, maybe the color is red. The machine can already detect, okay, this is an apple in these schools of thought. So an algorithm that is built on symbolism will detect this based on just those simple information. But if we look at the next school of thought, which is the connectionism, this is more complicated because the algorithm will look at this fruit not just because of the way it looks, but it's going to look at every single detail about this and create a full picture and detect this as an apple. Can anybody tell me any algorithm that use this method, this school of thought, the connectionism? Anybody tell us? Give us one example of an algorithm that use this. Anyone?
I think it's a CNN.
Yes, you have the CNN. So all the neural networks, because when you look at the CNN, if you look at this, if this is a picture of 28 by 28 pixel, if this is a picture of 28 by 28 pixel, what will happen in connectionism with a CNN, the convolutional neural network, it's going to take 28 pixel by 28 pixel, and take every pixel, whatever information is there, put it as the input layer of the neural network. So we're going to have 28 by 28, that is 784 input nodes in the input layer, which will be taken into the whole neural networks. And now the algorithm will learn from this. So during the machine learning process. So you understand that is connectionism. So connectionism is not just about how it looks or as simple as that. It takes every single detail of that. Okay. So and then we have the last one, which is behaviorism. Okay, or actionism. So when
Sorry, I'm muted.
oh, sorry guys, I don't know how I got muted. Okay, so when we talk about actionism, we actually suggest that intelligence will depend. You know, when you an example I can give you is um, if you take someone, we for those who watch soccer, they will tell you sometimes there is a good player, but as soon as that player changes the team, it goes into another environment. It goes into a new team with new with other players. That player cannot perform as well as he used to perform. So now, when we look at this now, we understand that the environment can also affect someone's intelligence. So the same thing works with the machine. So when we're looking at the behavior of, of the machine in a certain environment, so we can create an algorithm there. That's where we create all these algorithms that are used in robots, when you're creating robots, self-driving cars. Because when you look at the car, how will the car behave on the road when there's traffic? How will it behave when there's no traffic? How will the car behave when it gets to a traffic light and the light is red? So when we look at that now, we can create an algorithm, and then that's part of machine learning. We type of algorithm that use these methods is reinforcement learning, because reinforcement learning, we create what we call an agent. We put the agent in an environment and we see how the agent is behaving. Then we're going to punish and reward that agent, and that's how we train the model. So basically, let's say you are training your self-driving car to stop at a robot. You don't tell it that it's wrong to stop at a robot, but you create a function which becomes a punishment function. So, and then a reward function. So if it gets the robot is green. If the car pass when the robot is green, when the robot is red, if it's passed, then you're going to create a punishment. The punishment can be you have a certain score, you're going to -1 or something like that. So now the computer is going to try and accumulate more reward than punishment, and it's going to learn from that. Okay, so that is behaviorism or actionism. So you get yourself in the exam, you see they're talking about the three schools, they talk about actionism. You must understand actionism is the same as behaviorism. So it's all based on the behavior of the agent. Okay. So in terms of the AI development, remember that AI, the idea came from 1950. 1956 was the birth of AI. Um, uh, from with John McCarthy, right, who's considered to be the father of AI. And from that moment, we have a lot of improvement, different algorithms that came in. You have something very important that happened in 1997, where the first AI called Deep Blue was able to beat the world champion of chess, Gary Kasparov. So Gary Kasparov was beaten by an AI. So this was a very big news because now we could prove that computer could be better than human. So it was in the game of chess. And then the next one was, does anyone remember the next time a machine was able to beat a human at a game? Does anyone remember that? The next one was in 2016. 2016, when the world champion of a game that is most played in Asia, it's called Go. Lee Sedol was beaten by an AI called. Does anyone remember the name of that AI that beat Lee Sedol at the game? Which was very important because with that game, Go is not really like chess. You know, it was easy. It's easy for chess because that game Go is a game that involves a lot of feelings. It's not just about certain pattern, but an AI was able to beat a human at this game, the world champion, and it beat him by 4-1. Lee Sedol was beaten 4-1. Can anybody tell us? Does anyone remember the name of that AI? Anyone?
Or what was it? Alpha 07?
Sorry?
Alpha Zero.
No, it was AlphaGo. It was AlphaGo. So AlphaGo was that. Why is my screen blank? Can you guys still see the screen? Why is my screen
No,
blank?
sir.
Oh, you can't see it. Why is it blank? Give me a second. I don't know why my screen went blank. Completely blank. Yeah, the AI that was able to beat the Go player was AlphaGo. That was 2016. So that was such a big achievement in the AI industry. Sorry guys, I'm just refreshing this page. Slides. It's not showing. Yeah. You let me know when you see it again. All right. So we have AlphaGo in 2016, and we have in 1997 we have Deep Blue. Deep Blue. That's, you know. So these type of things, those are type of questions that can comes in terms of the history of AI. So when you get in your exam, if there's a question on the history of AI, it's usually on things like in which what year is considered to be the birth of AI. Maybe they'll give you an example like 1966 or 1976 or things like that. And then they may ask you the first AI that beat a human. And then you will have your Deep Blue. You know, when it's multiple choice like that, you have answers like Deep Blue close to that, you know. So it's very easy to get it wrong there. Okay, so we have Deep Blue, which was the first AI, and then AlphaGo came after and win the game of Go. Okay. Guys, you will just still loading. You let me know once you see the screen. Yeah. So we understand we have the history of AI like that. So that's what we need to understand about the history of AI. And if you see from the year 2010 the, the AI system or the whole AI industry has really been growing, with a lot of AIs, especially nowadays. There's an AI for everything. There's an AI that can do anything. Actually, today there's hardly any work that's that cannot be done by AI. And I think we've mentioned in the class what is the reason why there have been such a growth in AI. Is there anyone who can remind us again? Can anybody remind us why is AI so popular nowadays? Why is it easy to create an AI tools nowadays?
It's because of the evolution of computing power.
Yeah, perfect. You can see when we spoke about different CPU, GPUs, you can see how available now, and you can't really spend more because you can now even use them through cloud services such as the Huawei AI and different services. So that makes people access enough computing power, and because of that, people can actually train any type of model. You can take millions of data and let your computer learn about it and create a very powerful AI tool. So when we're looking at that, that is the reason why um, we are having this evolution of AI from the year 2010 until now, especially nowadays. It's really growing because of the growth of AI. All right. So the next thing will be uh, to when you're creating an AI tool, we need to ask ourselves a few questions. What problems are we solving? So we have three type of problems that we will solve. The first problem will be a regression problem. The second one is a classification problem. And the third one will be the clustering. Okay. So a classification problem means that the idea that we have, our scenario is a scenario where the output of everything that we are doing is going to be a certain category. For example, you are creating an AI to detect between male and female. You have two categories, male and female. You're creating an AI to detect between computers, cell phones, and tablets just by scanning the picture, so that AI is uh, having an output as a category, as a class. You understand? So that is a classification problem that you are solving. You dealing with an AI to detect human face. So what is the output? The output is a yes or a no. So is it the person or no? Or you dealing with an AI that will have to detect which student you're dealing with. So if you have a group of students, you have 1,000 students, that means you have 1,000 categories. So that is a classification problem. All right. So um, when you look at that, you have another scenario I can give you is you want to, uh, based on certain information, you want to detect if a student can access the exam venue or not. That becomes a binary classification because it has two outputs there, which are categories as well. So that's confirmed that we have a classification problem. Okay, so when it comes to regression problem, saying we are solving a regression problem will mean that the output of our uh, our uh, our machine or our model or our AI, the output is any value. So it can be any value, any discrete. So the output is discrete. So it can be any value. So in that case, we have a regression problem. Can anybody give us an example of a regression scenario? Anybody? Give us an example of a regression.
Sir, you are muted.
Yeah. Okay. I'm saying, I ask, can anybody tell us an example of a regression problem? Any scenario which is solving a regression problem?
Determining the prices of houses that are based on different characteristics.
Okay, yes, because the price can be any amount, you know, so that is a regression problem. All right. So, all right. Can you guys hear me?
Yes, sir.
Yes, we can.
Okay, I don't know what really happened. Okay, so based on those issues that we are solving, so we have a regression, classification, and clustering. So clustering is basically we don't have a specific class, but we will let the data based on the similarities create the Horn class. So that is an example that you see, for example, with your Netflix, with your YouTube, because you'll be watching certain movies. Now Netflix is now suggesting certain movies because they characterize you based on certain things that you like. For example, there is movies with the same actors, so they give you that. You know, when you look at if you take two phones, take go on Instagram. At the same time as you log in, you're not gonna get the same thing, the same content. Every content that goes there, it based on the user. So there is a clustering algorithm that has already created what type of content should be given to this person. And sometimes it's not just about what type of content they should give you. It's also based on the previous video. So if you go on your Instagram, for example, you're checking the Instagram reel, you realize that if you pay really attention, you will see the first video you get and the second videos have something in common. Sometimes in the previous video, there was a name that was mentioned, and the next video is posted by someone with a similar name that was mentioned. So in the previous video, it was a name of a person. In the second video, is the same name of a person, a similar name in the handle of the person who posted that video. I don't know if you guys understand what I'm trying to say. Or uh, in the first video, there can be a certain image, and then the next video. So there's always a similarity between the videos that they are giving you. So that is a clustering algorithm behind. Okay. So now that we want to solve all those type of problems, once we solve all those problems, we create AI models which can be classified into two types of AI. They can either we can create a strong AI or we can create a weak AI. And at the moment, there is no strong AI. Strong AI, why there's no strong AI? Because a strong AI is considered to be an AI that can think rationally. And so far, we do not have those type of AIs. So we do not have AI that can think rationally. All the AIs at the moment, they can only act based on the type of data they were trained with. They can't think on their own. They can't take their own decisions. So an AI cannot decide today not to do a certain job that the AI was created to do. The AI cannot decide today and say, I'm gonna stop doing certain things and do, you know, that the rational thinking is not given to AI. And that is very dangerous because at the moment we can achieve giving AI feelings and let them think rationally. That will be the danger of AI. So at the moment, all AI are considered to be weak AI because all the AI can only perform certain tasks as they were trained to perform. So they cannot they are not self-conscious. They don't know they exist. All right. So all the strong AI, you only see them in movies where AI decides, robots decide to fight humans in that. Okay. So we mentioned the 4 elements of AI. You have your data, you have your algorithm, and your scenario and your computing power, and all those elements will work in a certain infrastructure. So because we need a proper infrastructure, we have internet and all the sensors. So all these will help us in terms of dealing with the data, providing the data. So through the internet, we can collect the data and everything, and then we can now supply information for the part of AI, which is the data. So we can collect the data through the internet or collect the data through the sensors, Internet of Things, and all those things, right? And then through servers and high performing chips, all these computing powers that we can have, we can actually empower the cloud computing, which is where we can actually get all our computing power. So basically here we're talking about all the servers that you will need. So with powerful servers and the right data, we can now use this algorithm that we're going to create based on the scenario we're dealing with, and then we can actually create AI tools that will be in different technology directions, such as computing vision. That means that we're dealing with images, videos, we have speech processing, we have natural language processing, decision-making systems, and all these big data analysis systems that we can create. And this can be very important, very useful in the finance area, the healthcare, security, entertainment, and different other areas. Okay. So that's how we create all our AI tools. So very important, guys, the right computing power, as we've mentioned, the type of computing power that we have, the right algorithm. That means that we will need to know which algorithm we're going to use. So if you're dealing with an image recognition system, you must understand you need all your CNN, convolutional neural networks. You don't need another algorithm that does not help with image recognition. So it's very important for you to know which algorithm can help in what scenario. Okay, so we have many subfields of AI, such as some people will focus on big data, understanding how to use AI in big data. You have computer vision. Some people are experts in dealing with AI that has to do with images, So there is many subfields such as autonomous driving, object detection, and different fields. Okay, so we also have AI, obviously, being used in many areas nowadays. So those are certain things that can look at different scenarios where AI is being used in natural language processing, where we actually looking at certain texts, understanding the text and giving certain commands. You have your speech recognition technologies that we can implement in your light at home. You can just tell the lights to turn on. I think we we all get to a point where sometimes you your switch is far from you and you are lazy to walk to the switch. So you would like to speak to your light and just give a command to. For me personally, I would want everything in the house to be able to be smart enough to to listen to my voice, and that will make life easy. Yeah. All right. So we and now, and then we spoke about the Huawei full stack all scenarios AI solution. That means that we have, by saying that the Huawei, talking about the Huawei full stack all scenario, it means that we have scenarios. So we have all the services. So we have services in terms of the frameworks minus Poe, which can help you build models. Okay. you have CAN. Remember, CAN is an architecture that helps you connect all your hardware. And then you have the hardware products. You have some of them that are devices that you use. And then you have edge, for example, on your servers and routers. And then you have clouds, different servers that you can connect to in order for you to train your model and in order for you to use your model. Okay, so we have different chips that are created just for AI. Okay, so those are just examples. Okay, all right. Okay, so Saz, remember also the controversies over AI. Many people are so worried that AI is going to be the hand of us. AI is very dangerous. That is true because nowadays you can see how many people are victims of AI. People are using AI to create fake videos. You know, people are using. So now that becomes difficult because how do you get in court and prove that this person was on a crime scene, while today we can create fake videos using AI. So they can put you on a crime scene where you were not. That is becoming an issue now. A video or a picture is no more proof in court. But unfortunately, many countries are still judging people based on images. There's a picture of you on a crime scene. There's a video of you on a crime scene. They accuse you of the crime. While today with AI, everything can be done. Okay, so the biggest danger now with AI becomes every information that we have. What's real now? Because you open the internet today, sometimes you are worried about certain things that happen in certain countries, but all the images were just created using AI. So we need to worry about what we still see and what we hear. Is it reality? You know, what are the ethical issues of AI? How do we make sure that AI is not used in the wrong way? Right? And another important question, we have the question of privacies, because remember last time I told you that many of these social media are using our conversation, our pictures, and everything. They are using it in order for them to study us, in order for them to sell has certain products from other companies based on what we post and what we talk about. So if you have a friend of yours every day on WhatsApp, you're sending each other a message saying, let's go have coffee somewhere. So now the algorithm can see that conversation, and now you start getting adverts about coffee, or that information is taken to your other AI tools, maybe on your smartwatch. Next thing you get in your car, they're telling you are 5 minutes from the coffee shop, you know. So that becomes a problem. But two most important questions remain. Will AI take over our jobs? And is future AI controllable? This is very important, because if we all now having self-driving cars and they can control whatever you do with your car, they will control where they want you to go. You understand? So that will be very dangerous, because once a hacker hack the system, they can kidnap you in your own car. That's the danger. Will AI take jobs? Of course it will. But we're getting to a place where the people who are going to get jobs are the people who know which AI tool to use in the field of study or field of work. So if you're working in a certain field, you need to make sure you know every AI tool being used in that field. Even as a developer, if you don't know about AI tools, you will be working on a project for 3 months while you could have done the project in a week. There is a lot of AI tools that can help you achieve everything today. So it's very important to understand whatever job, whatever field you are, you need to understand which AI tool is being used in that area and make sure you understand how to use that AI tool. All right, guys. I think that will be all for today. Maybe we can just stop the recording and then we can turn on our cameras and yeah, second attendance.